Hello, everyone. Welcome to NCR course module 7, the last official class. So thank you, everyone, for being here and for kind of coming with us for this kind of first, hopefully, of many intro courses to Web3 research. So I guess, Chloe here, helping to lead and facilitate most of this class. And I will also be kind of the lead instructor for today's class as well. So today is November 29th. Awesome. Got the right time. That's perfect. We're going to do this for about an hour. We have our past modules for review. So I'll kind of just go through them all since our last class, and it's kind of been a lot we've gone through, but we went through the foundations of blockchain and near protocol, where we were kind of just like, what is a blockchain and what is the blockchain space and what are we maybe researching and what is near? Why does this blockchain exist? What problems is Near trying to solve in the Web3 space? We talked about how, there was Bitcoin, and then, Ethereum came about with smart contracts, and then things got kind of expensive on there as everyone started throwing all of their smart contracts on Ethereum for DeFi and for gaming and NFTs and everything else. And so eventually Near came about, where they were working on, sharding and, being proof of stake, and now Ethereum proof of stake as well. But that was kind of the journey there. We went through methods for blockchain data retrieval, like how do you use a blockchain explorer? So these are kind of dashboards that help you search through transactions like Near blocks or Pikes Peak, or just the old-fashioned Near Explorer. We went through data transformation and visualization techniques, either with Google Sheets or with even using GPT-4, for example, and able to, even if you're not technical, you can still put data into GPT-4 and transform that using AI tools to help. And then we went through module 5, which is kind of where in my opinion, a lot of the fun is still happening, where everyone in the class was invited to kind of choose a topic or learn about even how to choose a topic, and then kind of write up a one-page, just ideas, links, about that topic. And then obviously kind of trying to have it be coherent into a paper of some sorts. And then over the next month, we'll kind of be turning those into projects. So we'll kind of go over that, I guess, near the end of the class, and people can definitely ask questions. But just for now, something to kind of mull over in your mind is the idea that you don't have to alter your project much further, making sure there's a name on it, like who you are as the writer. The class you took part in is probably important as well. If it's going to be a paper, maybe even the facilitator name or other key identifiers of the class, if it's going to be a paper, right? Also kind of trying to outline like the introduction or title page of some sort, maybe, kind of some appendix with, I know some people have added pictures and stuff. So instead of having like the full image in the middle of the article, potentially maybe an appendix to be like, as referred to here. Not necessary, just things to think about. But also thinking about, it doesn't have to be a paper, right? So if you decide to kind of use your kind of article so far as talking points, and you want to record a video, that would be great as well. You can do that, and we have you can use various tools to help you create the videos. So kind of feel free to be creative with how you kind of submit your projects. I'm kind of here to help people work through that over the next month, but you are very definitely feel free to kind of submit a paper with just like your name, the class title, the topic, an introduction, the observations, like kind of what you've seen, and like honestly, if you have any questions about like how you want to format your paper. Anyways, then we started going through the more specific kind of, where has blockchain shown its use? So, if someone's talking about blockchain, a lot of times they're talking about, governance, like the NDC, they're talking about DeFi, like Ref Finance, they're talking about NFTs, like Mintbase, talking about blockchain gaming, like, Marmaday gaming maybe. For today, we'll be talking about, zero knowledge on Near and some other Near integrations that Near is working on. If you're a developer, if you're someone who wants to understand the world better, if you're someone relatively technical, it does start from a simpler place. So they have they have the internet, email, and then number theory. It's kind of shown backwards here. I can probably zoom in a little bit. So it'll explain to you first what the internet is, how it works, and from like the most basic steps. So anybody, I promise you, like I gave this to my mom, to the internet one, and she was able to read through it and follow along. So anybody can follow along. It goes in depth through every single thing from first principles. What is the internet and how do we connect? And you'll learn it's all about cryptography. And that's, how do you secure the internet? And that's kind of, and it's kind of web, web 0, web 1, web 2, web 3, haha. I mean, it's the most beautiful website I've ever seen in my entire life, to be honest. This is like amazing. Then it goes through email. Like, how do we then take this internet and then communicate with one another and create value from that and create, value of exchange from that? And then after email, you kind of get, okay, well, if we could have encrypted communication going back and forth from one another, how do we then use number theory and, complex cryptography to then hide things in public, like hide numbers in public, which is like, I guess, my love of this whole thing. So the whole reason I'm here and the whole reason I love blockchains and Web3 and cryptography is this whole number theory thing. And so I'm not going to try and go through this very, very, very long article. It goes for like a very long time, and it's very complex and in depth. And all of these, so if you ever want to learn how to write articles, this is like the most efficient articles I've seen. There's like links within links, and then going to other links and definitions that go to other parts of the article. Quite efficient. It's beautiful. So number theory is the study of integers, so just numbers, 0, 1, 2, 3, and the relations between them. So again, from the idea of how does it relate to us in cryptography from a non-technical point of view, it's these integers, these numbers, and how they relate to each other and how we hide things or hide numbers in between them as an idea. So it can get kind of complex, of course, but so when you're using the blockchain and you're, let's say, using your account, let's say Chloe.near, sign a transaction, I'm proving that I signed it by this idea of having numbers and hiding them within each other. We don't really need to go into too much detail further than that. Anyways, this famous dude, Carl Friedrich Gauss, allegedly said that mathematics is the queen of the sciences and that number theory is the queen of mathematics. Lovely quote, just to mean that mathematics, unlike empirical sciences, studies regularities which are independent from the universe that we live in. This article, at least, I think is a little less technical and tries to explain what are some of the primitives that are included in blockchain technology. So a primitive is just like a building block that other people can use to keep, building cryptographic tools, or like blockchains, for example. So when Near wanted to, so we've all heard of a block hash, for example. Here we can kind of see the live transactions on the Near blockchain, and we can see that there's hashes that are all coming through. So this AR or XS, there's so many going through. But we can see that each transaction could be linked to a hash. And so what we're actually having is this cryptographic primitive, this building block called like a hash function, where you could take all this data and kind of condense it down into a bite-sized. And so, this kind of random string will always link to the data that's inside of it. That's all that it means to have a hash. Why do we need these building blocks? I think of Legos back in the day. Buying Legos from the store makes it a lot easier to build a nice high tower. You could imagine if you build that, if you just do it yourself, it'd be a little more difficult to build with sticks in your backyard, to build something that's as secure and that's as sturdy. But the same thing is true in a cryptographic sense. By having primitives, we're able to actually have these tools. For example, back in the day, the NSA and MIT and these big universities and the US government would work on these cryptographic primitives. And actually, it used to be like a war crime to take this code, these building blocks, and move them to other countries. So for example, someone in the Ethereum community actually is still in jail for teaching, allegedly teaching North Korean developers how to use encryption to circumvent sanctions. And so you can see how these building blocks are super important, and knowing how to use them, it's very difficult to create your own. Even the North Korean government would potentially have a hard time. And so, if you do have a really secure building block, you can trust to build on it in the future. That's what everyone kind of does for now. You get encryption and decryption. So we all kind of are very used to it now. But back in the day, the internet was not private. There was no privacy on the internet. The whole idea, you need to encrypt something, that came about after, where you actually have to encrypt this communication. And very quickly after, people realized that if you want to be able to communicate with someone, you need to make sure that it is encrypted. And it's just like when you have your mail, you write a message to someone, you have like the message, you have the sender of the message. Like, let's say I'm sending a message to Rhoda. I'll write some communications on it. I'll put it in some envelope, and I need some way to, have it be private. So seal it in the envelope, send it over to Rhoda, and then Rhoda needs some way to actually decrypt it, right? To open that letter and read what's inside. And so there's a few different ways of doing this. When you get into cryptography, you realize the high level really is that simple, but there's many ways to go about it. Like you can lock the box the message is going in, so anyone with the key can open it and read what's inside. You could actually make so the message is scrambled so that maybe anyone can open the letter. So maybe, for example, you could imagine when you send something across a border and you have a customs agent, maybe they're going to open your package anyways. So maybe your package is not so secure because the government is going to open your package, but maybe the actual contents is scrambled so that the person opening it doesn't know what it is. And so there's actually different ways to look at encryption and decryption, but that is the high level idea of the primitive. Validation, seeing if something is true. And so we see the blockchain useful for this all the time, where let's say even NFTs, right? We're able to validate that someone created a specific NFT or the store it's on because of the smart contract. And the specific primitives are kind of listed here. And so the number theory explained article that I have here, that's very, very long and very, very in-depth, goes through all these same things. So linear one-way functions and, but it goes through like finite fields and all the math. And so the same things here, one-way hash functions. Technically, these things don't really exist. They're kind of theoretical. It's kind of funny when you actually start learning about it, but it's a mathematical function used to encrypt variable length data. So you can imagine transactions on the blockchain, right? Variable length data and into fixed binary data. So instead of being potentially very, very large in length, or even potentially very, very short in length, it'll be fixed, always the same size, so easy to handle. Imagine trying to juggle and having like a small ball, a big chainsaw, and then a stick. It'd be very difficult. It's much easier to manage complex tasks when you have everything being the same size. And that's the same thing for blockchains. By hashing things, everything is the same size. But it uses, there's symmetric key cryptography, asymmetric key cryptography, which is used more in blockchains, like your public and private key. You have your Chloe.near account, for example, like your Han17.near. Then you have your private key you want no one to see. And that's just asymmetric key cryptography. You have randomized algorithms. So for example, this gets a little more technical, but even in Bitcoin, for example, right? Bitcoin was trying to be very simple with their randomization algorithm, which wasn't even a random. Anyways, in Ethereum, if you want to choose who the next validator is going to be, you have a randomization or an algorithm to choose random numbers. So it might seem very simple, like how, let's say you want to choose a number from between 1 and 10, choose 7 or choose 3. But on the blockchain, it's actually very difficult, but very important to be able to have a random number that's generated. So cryptography is used to ensure that all the validators can take part in choosing a number and that no validator can cheat. Because you can imagine with all this money being secured by blockchains, if people were cheating and knowing what these random values, they could maybe, you could even think of a game on the blockchain. If you could cheat and know what the next value is going to be, you might be able to cheat and win the prize or win the pot. Or you think of Mario Kart on chain. If you were able to cheat and see what the random value inside of that question mark box was going to be, you could always get the best power-ups maybe, right? And win the best prizes. Now, those could be simple and silly examples, but there's also sometimes lots of, you could think of just very simple casinos on chain. There's very large, like pool together, for example. For example, 3.3 million in prizes won. I thought it was larger than that, but that's cool. But you can imagine if someone's able to kind of, okay, I'm not going to go through, it's way too much. If you ever build an application, maybe it might be a good idea for UX, user experience, to not make it so difficult to actually get to your application. But how it is these days. But anyways, you can imagine if this is built on chain and someone's able to kind of see the random numbers, that could be, $3.3 million, taken. There's much larger pots, but that's just an example that could be seen there. A bunch of other ones. I'm not going to go through them all. Again, if you find this interesting, please feel free to keep reading more. This is kind of what NEAR is using in terms of cryptography. Now, again, people here in this class, for example, might not understand specifically what's going on here, but the idea is this is all you need to know. So when you go to the NEAR docs and you go to how are, cryptographic functions used, this is what NEAR Foundation is showing as its technical showcase of how cryptography is used. So this is my way of saying there's this month-long article. If you actually, I think everyone should go through this. I think it's actually really cool and really valuable. It's probably a month of your life or more. So maybe put it there for a year from now, or just kind of bookmark it. It's very valuable though. But when you're actually building with cryptography, this is pretty much all you need to know. Let's zoom in and let's read through it and see what a cryptographer would be reading. So, about NEAR protocol. NEAR protocol specifically uses this cryptographic library. So we can actually, let's not even read it, right? Let's just, this is how I would actually do it if I was looking at let's say I was looking up Solana or Avalanche, and I was trying to do a survey on what cryptographic libraries are these blockchain protocols using. There you go. So now you know that this is a curve. So you could actually go to principles once again, and so let's say you had no clue what that was. Everything can be found back here. Curve right here. Bitcoin, Ethereum, and many other cryptocurrencies use an elliptic curve called this thing, I'm not going to try and pronounce it, I'm sorry, in their signature algorithm, which is defined in, so it's standardized, right? And there's a group that standardizes these things. Again, that's the building block. It's a primitive, and then the letter P. So then you have to actually read through all this math stuff. So don't worry about that. But hey, you could just kind of stop here and be like, okay, this is what it is. Awesome. And they use this. Okay, so if you were confused and didn't know what this was, again, you can Google it quickly and kind of see, okay, what is this thing? Okay, it's a public key signature algorithm. I think they use this one for the accounts. So I think Chloe.near, HANA17, XVII, I think those are all secured by this public key signature. And this is used for the actual validation of the blocks. Not that anyone might care. I'm just kind of saying. Oh yeah, so yeah, and this one for account keys. And yeah, this one for signing. That's it, yeah, perfect. So it was written right there, why not? And then if you want to know where this stuff comes from, here you go. You can actually find the library and read the code the cryptography is written in. So NEAR Foundation or NEAR Protocol, NEAR Inc. does not write its own cryptography code. It's not how it works. There is a open source repository of code. So again, we can zoom in a bit, sorry. When you want to create a signature, it's simple. So again, there's a message. Like I said before, if I'm trying to send a message to Rhoda, you need to sign it. Just let's say, if you want to send a message to the bank, a lot of times it's very easy to think of it that way. Your message to the bank is your check, and you have to sign your message so the bank knows it's actually you. And imagine you have a special pen to sign with, and it's this ED25519 pen. It allows you to sign your signature. The bank knows it's you, and they can verify it. So there's signing functions, there's verifying functions. You can I know this stuff looks complicated, but on a random line, like you're asserting that the signing key, there's already a function built in. Remember, you're not writing this code. Someone else already wrote this verify function, and you're going to verify that the message matches the signature, and there's already a function that checks if it's okay, and you're just going to verify that and on the signing key. So programming is complicated, but arguably these days this is an open source, very well-known library. And for example, you can go to GPT-4, and if you are super confused by this, you can just take this information and like step by step be like, hey, can you explain to me how, Near protocol would use this signature algorithm to sign a use Chloe.near to sign a message with a private key. And I promise you, it'll lay it out in very, very simple terms. So if you're technical, you can read through it here. I know this can be, again, it's hard to understand, to get used to reading things like this in this type of like coding language, like in Rust, I guess. But if you're not used to reading Rust, please, don't just stop it. Don't just stop. Just copy and paste it and throw it into GPT at least, and it'll reword it and just say, hey, can you reword this in like normal, whatever language you speak, like in Spanish, please reword this from Rust into Spanish, and it'll just reword it for you so you can read what's happening. I'm going very slow, sorry. But that's all I really want to explain. If you ever want to be able to speak to someone like, hey, how is Near, secured? Oh, by cryptography. Okay, well, what does that mean? Well, you can say, oh, like these specific libraries are being used and they're written in Rust. Okay, what does that mean? Who works on these libraries? Well, you can say, well, MIT a lot of times the NSA worked on this library. So when someone say, okay, well, is that actually secure? Like, what's actually happening here? Well, but you know what? SHA-2 was, helped develop by the NSA. Back in the day, these things were, developed by MIT and, government agencies. And there's so many different algorithms for hashing. And actually, a group of Indian university students just broke one of the hashing algorithms that came out before this. So these things do get broken. That's why they're important to make sure that there's one someone's using. So again, when someone asks, why is it secure? You can say, okay, well, this is why it's secure, but also why it's not secure. These functions are not actually one way. So if someone ever says these functions, like blockchains, are secure, you could actually say, well, no, they're theoretically secure. Technically, these hash functions can get broken, and actually hash functions specifically will get broken theoretically one day, all of them, because computing power, technically, quantum computers will break hash functions and a bunch of other things. A very high-level overview of cryptography and blockchains. Hopefully you learned something, and if you were interested, hopefully you learned where to go. This is where to go. This article, I know this part of it might be daunting if you're not technical, but it is from first principles. So it will take it slowly. And maybe there's no reason to ever know that, this is not what will get you hired. It will not get you a job probably anytime soon, but it'll help you understand the world in which we live, all of the applications we use, the internet, and everything else that we engage with. And if you do get stuck on that number theory article, just go to the internet one. That one's very fun and lighthearted, and it'll be more into what you use every day, like Netflix and Facebook and Instagram. Anyways, now we're getting into zero knowledge. I like zero knowledge proofs because they're very simple from the get-go. Actually, does anyone, before we get started, I'm actually curious. I'm actually going to go to a different, the answers right there. Does anyone have, you can type it out or you can say it. You might have read it already. An idea of what a zero knowledge proof is. If you might have seen it on Twitter, for example, or if you're in DeFi, you might have seen ZK EVMs, zero knowledge, Ethereum virtual machines, or you might have seen, other zero knowledge things. Does anyone have an idea what zero knowledge is, or zero knowledge proofs are, or any of that, or should I just keep going? If no one has, zero knowledge at least might be somewhat. I'll go for, I guess, maybe what I used to always think of it as, before I started doing research. And I guess for me, it was always more about the privacy aspects. The idea of everything is public on the blockchain. And that obviously seems like an issue sounds good. Thank you. Yeah, so for me, I always felt like zero knowledge proofs were some way to use advanced cryptography to keep things private. And I know we have Calamaro network, for example, on Near, which is, trying to have privacy on chain. And I always felt like that was the main use case. And I guess, without taking too much time to move forward, what I found to be interesting is that even when you learn about zero knowledge proofs, a lot of the learning is about the privacy aspect. But when you actually want to get a job, if you ever wanted to work for a zero knowledge company or work for a cryptography company, let's say you just thought cryptography was interesting or you wanted to keep researching in the area, you'll quickly realize that most people don't actually care about paying for privacy. Like when you use Snapchat, you're willing to pay for privacy from your friends, right? Where you can send a snap and it disappears and you know that they probably can't see it. They can screenshot it again or whatever, but you get some false sense of privacy. People will generally pay for that or use that, but people won't pay for absolute privacy. Like people won't pay 10 cents every message to make sure their texts can't be seen by like a global network state, like a government, like a world government or a global actor, like the NSA. Generally, that's a general statement. But people will pay for higher transaction throughput. So actually, we can go through this. Like a zero-knowledge proof is a method of proving the validity of a statement without revealing anything other than the validity of the statement itself. So it's being able to say something really did happen without having to go back and be there and see it happen. I use a lot of funny examples, but there's some examples in this article which are kind of more traditional, and I won't kind of go on a funny tangent, even though I think I'm hilarious. So kind of jumping down a bit, in cryptography, as zero-knowledge proofs let you convince me, right, that you know something or have done something without revealing to me what that secret was, right? So you have some secret, like you told your friend a really embarrassing secret about yourself, and you don't want to tell me, but you want to be like, no, I really did tell this person the embarrassing secret. I can't repeat it to you, but I really did do it. You got to trust me. But with zero-knowledge proofs, you don't have to trust. It's, well, theoretically, by probability, it's proven. Three things that ZK, I'm going to call them ZKPs from now on because I think it's a lot of words to say quickly. So to have a ZKP, you need to satisfy these three properties. So if you don't remember anything else, remember ZKPs help you prove a statement without, that could be a secret without showing the secret, right? So you can prove something without showing it. And you need these three things: completeness, soundness, and zero knowledge. And that's just going back to the same definition. This is actually the full technical definition. So I'm going to read that out just so we have it done, and then I'll move on. And I think this next example will clear it up if anyone's still confused. So completeness. If the statement is true, an honest verifier will be convinced by an honest prover. Okay, so if I'm the prover, okay, I am the P, I'm the prover. And let's say, Hannah, you're the verifier. You're going to verify the statement. So we have a statement, we have a prover, we have a verifier. I'm trying to prove something. So if I am telling the truth, Hannah will know it instantly. Hannah does not have to go be curious again. That was what it was. It's not like I can say something and then Hannah's like, okay, well, now I trust you more, but I still need more proof. No, if it is a ZKP, if I prove the statement and I'm being honest, Hannah should know instantly. And if I'm not being honest, that means by proxy, Hannah should also know if I'm lying instantly. Soundness. This is the other. Okay. If the statement is false, no dishonest prover. So if the statement is untrue, and I'm a bad person, I'm trying to lie, I will not be able to convince Hannah that of my lies. The proof systems are truthful and you're not out cheating. Again, this is like we're restating the same thing, but completeness is about the truth of it. Soundness is saying that you can always check if it's false. And zero knowledge. This is kind of the key component that helps blockchains, or helps it be so useful in blockchain systems where everything is public. If the statement is true, right? So even if it's true, kind of that's the way I think of it, no verifier learns anything other than the fact that it's true. So I'm able to verify this thing without giving you any details as to what happened. So you can think about, I'll use one that actually I use and that's not as funny. Think about going to a bar. Let's think about the fact that some people don't want to show exactly what their age is. They don't want to show their face. They don't want to show their address. That's kind of maybe a bit like, I feel weird about that kind of stuff these days, actually, being in crypto for so long. When I go to a bar, I don't get carded anymore. But, let's say you get carded at a bar and they see your ID. Well, they get to see a lot more than just your age, right? They get to see your signature, your face. They can kind of see your identity. You can imagine when they let's say like in Canada, for example, they scan your IDs in some places. They could be scanning it and actually copying your ID and trying to steal your identity. Where you can imagine a ZKP system where you're actually able to prove you're above a certain age or between a certain age without actually giving details as to what your age actually is or any other details about who you are. That would be a ZKP system. So very straightforward, actually, and it's used all across, all over the world. But that is a ZKP system. And then you have interactive ZKPs, and you have non-interactive, which doesn't really matter. And all of this doesn't matter either. But this example is, I think, one of the best ways, and it says to a child, but I think it's a bit silly and maybe condescending. I just think it's a great example. It doesn't have to be to a child. But anyways, the next example is just way more confusing. But anyways, the simplest way to prove that you have knowledge of something without giving it away can be often shown using Where's Wally. So if you've ever seen Where's Wally before, this is the example. Let's say there's I'll kind of go over it without reading through it all. Let's say there's like a $10,000 Where's Wally prize let's say on the blockchain. And it was given out, huge Where's Wally board was given out, and all over the world people were looking at this and trying to, see where Wally was. How would you actually prove you knew where Wally was without just shouting it out and saying, here's Wally, and everyone else would know? So by using zero knowledge proof, imagine in this example, you were able to take a piece of paper, and they're trying to show it here, where take a piece of paper over the Where's Wally board, cut out a circle, and only showcase the Wally. That way, you'd be able to prove you actually do know that Wally is right here, without kind of showing where in the entire picture Wally is. So if someone tried to guess and find that spot, let's say this canvas was thousands and thousands of times bigger, right? In an actual zero knowledge proof system, this is the idea, but the canvas would be like millions and millions, billions of times bigger. And this circle would be, billions of times smaller, but it would be the same idea. Someone would be taking a piece of paper, showing a location of a picture, being like, hey, this is Wally, so I obviously know where Wally is. And so if someone else tried to find Wally using that picture, they wouldn't be able to, because the size of the canvas is too large. And hopefully that kind of explains ZKPs in a simple sense. What I think is even cooler than random ideas of where this can be used is Nearweek's article on where zero knowledge is already being used on Near Protocol. So let's say after this class or in the future, you wanted to write an article similar, let's say for Nearweek. Nearweek does have, I think, community writers come on board and write for them. This is the kind of idea. You could see this is kind of a project, doing a survey on the various zero knowledge projects using the new technology on Near. So I think this is a great article to go through. I will share it in the link once again, and if people want, they should read it. I am going to skip through most of it. I'll go through a bit of the intro, and I'll go through a few of the projects. So ZKPs have landed on Near. Woohoo! The breakthrough privacy technology, and again, it's not just privacy. We haven't gone through much of it yet. We'll go through it here, but it's also for scaling. So whenever someone says ZKPs, everyone always thinks of privacy, but you should also be thinking about scaling. If you could have data that you don't have to verify, but you know it's true, that data could also be blockchain transactions, right? The whole idea of a blockchain is to be able to hash things, take all of this data and bring it into a smaller block that you can verify in bite-sized chunks, right? That's the whole idea, to make it fast and efficient. Well, if you could take even more, these are rollups, right? If you could take a bunch of transactions and then using zero knowledge, verify millions and millions of blockchain transactions in one small block, that would be also the use of a ZKP. And this is the future of blockchains. Making them, many, many times more efficient is actually not for privacy, but for scalability. Sorry, I just gotta make sure, I feel like this is like the coolest part of ZKPs is like not I love privacy. I'm a privacy geek, but the actual way we're going to get 1 billion users onto blockchain is from ZKPs and the ability for your phone, for example, to be able to verify the entire Near blockchain very cheaply, because you don't need to actually have knowledge of what's happening. There's a proof. Ha ha ha. Anyways, while zero knowledge. Okay, yeah, so I got stuck on the privacy part. The breakthrough privacy technology is being implemented by multiple projects within the Near ecosystem, helping create an extra layer of privacy. See, there you go, while increasing scalability, but I don't think we're highlighting scalability enough, and security in equal measure. While zero knowledge technology is complex and has historically been inaccessible to many developers, Near's goal is to make these tools easy to use for developers of any skill level. Okay, and then lots of information. But ZK Lite client. So this is actually really cool. This is what I'm talking about when I talk about our phones being able to validate the chain. So to me, this is like where I want to, like, if I'm being 100% selfish, this is where I would like to see the research collective have like a full class and cohort. And look, they're a Web3 development organization. They are basically like as if the research collective had a dev team and started like going to other projects and shipping stuff. So when I say the NRC could like hire some developers and start shipping some small, like I think one of the coolest first projects. So again, XVII, Hannah, and then Ernest, if you guys ever come together and decide it's a good idea, one of the coolest ones would be partnering with Mintbase in their grants program and having like a research publication platform for NFTs, where you can just simply go on Boss, start writing, publish an NFT, it gets listed for sale. You can choose whether it's royalties or whether you want it to be for credit card, and put some money towards charity if you want, and then just publish. It would be awesome. But yeah, anyways, Zpoken, right, is a platform like this that builds projects and does research and is on the bleeding edge of the latest practices, and they built a ZK Lite client, or they're building a ZK Lite client. For interoperability with Near and other chains, works in browsers. The idea is you can verify from a browser. You can be on a phone or a low-powered device, and you can be on your data and still be able to verify not only Near transactions, but also cross-chain transactions. Awesome. This is the future of blockchain. This is awesome. Hide your cache. I think the homework has to do with hide your cache. I think that's one of like the coolest. Again, I'm more about privacy. Again, feel free to use other things, but hide your cache allows you to hide your cache. They actually changed their name. It's like Opact tokens. I actually like the old name better. I'm sure it was like very sketchy and made people very scared to use it. Like, what? You want to hide my cache? That seems very sketchy. Very interesting platform. Allows you to, I'll do it here. I feel like if we're going to do it for the homework, I should at least do it live first, if I even have enough Near in my account. I think I might have one Near in there. I don't keep very much Near in my accounts. Maybe I can take some off ref in the last few moments of class. You could choose a token, Near or Tether. So you could, I've thought about using this, and I probably will use this in the future. I don't like it hasn't been audited. But anyways, I do like helping platforms on here, but for payments, for example. So even if, let's say you had like a few employees on Near, you could actually be helping the anonymity set. So the size of the anonymity on Near by just, paying out people using this, or even paying your friend back, right? If you owe your friend, $5 USDT, you can use this. But I have Near in my account, I think. You could choose one Near, and it'll show you, I don't have enough, so how much the current anonymity is, right? So you can read more about what best practices for anonymity. You can learn more about anonymity, and this is kind of where I would love to do a whole class later on specifically just privacy, maybe even on Near and understanding the score, and like research into this stuff this is the whole other class just on this. But anyways, I'm gonna choose one Near. I'm gonna deposit. The number below is my withdrawal ticket, and it downloaded it. Good. Okay, so the way this works, I'm gonna be very clear because this can be confusing. This is the hash. We're using zero knowledge proof, right? So this is the proof to get my funds back. So if I was sending this to a friend, It says wait 30 minutes. So 30 minutes, I can have a bunch of these tickets saved in my, private folder somewhere, right? And then whenever I owe someone one near, I could take one of these hashes or one of these, random strings, and then I could send it to them and they could use it in this platform and get the one near. So let's deposit now. So they generate the hash first, and then they use the hash, right? So that's the final answer, right? That is the final proof. They then use that proof and attach it to my deposit, if that makes sense, to the value. So then they know, it's a blockchain, so they know 100%. I mean, there's more information. I should have looked it up. So this is the secrets hash, right? So this is the public thing that's going to go on the blockchain. So this public secret hash has all the details of the one near thing, that it's one near. And so when someone puts the private hash into the page, it'll search up that public secrets hash that's right here and find it and know that it's one near and give it to the user. Hopefully that makes sense. Hopefully this sends. It probably just takes a bit of time because it's probably generating stuff in the back end. There you go. Funds deposited successfully. Please wait 30 minutes to withdraw. So if you lose that, let's say you didn't save, you didn't control, or you lose it, or you save something else, you forgot, it is now saved in my folders. In my downloads, opact-1 near.txt. So right here, you can see this is the random string. And so I am going to put it in the near certified researcher chat. And so the first person to go use that will get one near. It might take half an hour. It might take 5 minutes. It might take 1 minute. Last time I did it took like 30 seconds to a minute, I think. But there you go. That is a way to use privacy where technically you could have your entire, don't do this. It has not been audited. As an example, let's say eventually this does get audited and the primitives, right, are more well used in near. You could imagine having your DAO built on this, or having your savings or whatever else built on this, and being able to actually having a wallet that uses this primitive and allows you to transact back and forth privately using these tickets. It might work right away. It might not. So feel free to, so for example, we want to withdraw, take the ticket from right here. Let's say, I'm not going to actually do it, right? Take the ticket. It should say it's correct. Yep. Put chloe.near. And when it says it's correct, it should allow you. And here you go. Yeah. See, it's working. So someone can do that right now. I'm not going to do it. That would be like not very, but you can see there's a protocol fee and a relayer fee. So they take some fees. So you lose some fees, but you get privacy. And you can see that there's not very much privacy. Let's say if I did like xv near. Okay, so not very much privacy because it hasn't been there for very long. So people would know. They're saying, again, this is their idea, and this is the whole research element. Like I'm telling you, like this is if you could help Opact tickets create more anonymity and like create like let's say you made a game. Marvin J Gaming could be an example where to play this game, everyone paid one near. Well, let's say instead of one near going into a random pot, it went into Opact tickets. Then you could actually make it so that people are using privacy in this game and increasing the anonymity set, which could create value for that team, and maybe there could be a grant for that, for example. And these are kind of ways in which you could imagine having a greater understanding of these tools could actually get you to potentially, propose some of these, ideas to these projects in fun ways. But anyways, that's Opact tickets. Okay, so in this article, the aim of the type is to allow for greater interoperability across chains. So I dislike usually these types of articles because they're very markety, and usually it's just like. But anyways, I think it does give a general example of what Near's plan is, what the vision is, and I think the whole ZK WASM is amazing. Like this is basically Near blockchain becoming a prover for other blockchains. It's very cool. But anyways. The Near Foundation, the nonprofit behind the Near protocol, has announced a collaboration with Ethereum scaling protocol firm Polygon Labs in an attempt to improve interoperability across chains. The deal brings Near protocol closer to one of the largest blockchain networks, Ethereum, and enables blockchains with WASM technology to use Ethereum's liquidity, according to a press release. So WASM is kind of, in my opinion, like the future of blockchains. It just allows for greater interoperability, not just within blockchain, but also with like the languages you can use to build in the blockchain and everything else. So Arbitrum just launched Stylus, which is their like WASM enabled writing contracts on Arbitrum. Near uses WASM for like writing Rust and other contracts on Near, and obviously Polygon also is working in this area as well. And so this should allow, I mean, in the future through in development and interoperability layer. So again, this is in development so far. This layer isn't built yet, but chains will be able to access shared liquidity in a unified ecosystem. And so basically, but you don't have to stop if you're building on Ethereum, like a WASM-based EVM, or you're building on Near, or you're building on, let's say, Arbitrum. You'll still be able to access similar liquidity and not have to build on a whole new chain. So, like in the current system, I'm sure people have seen like Uniswap, for example. I mean, we could show this for example for sure. Uniswap. I guess V3. Let's see what goes when you have to home. But it gets very confusing. When you try and launch the app, from my understanding, I haven't been on this app in a very long time. But there's lots of different protocols to come from, and as a user, you have to choose. So this, I think, is like the current state of blockchain ecosystems, and I think this is definitely changing with like ZK WASM. The idea that you just come from, let's say you're coming from Near. Right now, if you come from Near, you do not have access to all this liquidity. And right now, if you come from Arbitrum, for example, you don't have access to liquidity from other chains. With the ZK WASM, you would just come from, let's say, Celo, if that was your chain, and then you wouldn't even need to care about the other chains because you'd be able to sign transactions from Celo and interact on other blockchains. And so that's the idea of the ZK WASM, being able to use your account on your blockchain, have like a base interoperability layer, interact with other blockchains that are using this interoperability system. But the idea for Near is that with Boss, you get an interoperability on the front end layer as well. So now with Boss, you could actually be using Near without knowing it, interacting with Arbitrum, and then actually be using Near liquidity without knowing it, because you're using your Arbitrum, let's say your Optimism account to use an Arbitrum-based DEX that's kind of pulling liquidity from Near protocol as well. And so that's kind of the idea, is build it using cryptography for interoperability. I think that's kind of, in my eyes, how are ZKPs helping us? I think this is the future. ZKPs are helping us on the blockchain layer by giving us full interoperability so that we can onboard our friends to Near with like mint-based wallets for free on their phones. And they could still be interacting with Uniswap on Ethereum or Arbitrum one day and getting airdrops back to their accounts, which would be super cool. At the same time, it helps us build these really cool applications like Opact tickets, where we can actually have privacy with our funding and like anonymously, like, no one really knows, how whoever claimed, we don't even know who claimed it, I guess, for now, but whoever claimed, I guess, I could even use this to send funds to other people, right? And no one really knows who sent that money to this person. So if I wanted to do an airdrop, for example, I could use Opact tickets to do an airdrop where no one even knows where the airdrop came from. All they know is it came from Opact tickets, and that could have been from anyone. So there's just ideas to think about when thinking about like privacy and ZKPs on Near.